brought to you by MuleSoft, provider of the industry-leading Anypoint platform for APIs.
So I'm Holger Reinhardt. I'm a business developer, technical strategy, yada yada, API Academy of a company called Layer 7. We are sharing a lot of things with other companies here on the floor. We're doing API management, but my task really is more to look at how the future is going to affect our products, so that maybe 2 or 3 years down the road we still have products we can sell. So, topic of this talk is, but you guys have heard of IoT, right? Okay, some at least. So, Internet of Things, right? When I started talking about Internet of Things, like in 2013, I was literally the first guy in the API field who was mentioning it. Summer came, 2013, and in September it kind of, you can actually see that on Google Analytics. The interest in IoT kind of went up, straight up, and now essentially it's you can't really escape that hype anymore because everything is IoT, right? Google buying Nest for $2 billion, and I think IoT and chat apps are right now the hottest items. So if you have a startup right now, build either chat apps or something with IoT in it. I think then your valuation kind of just goes through the roof. Anyway, the interesting thing is, so my first slide, when you talk about IoT, I actually like to have this slide, and you can read it for a second. There's an old Jewish saying, right? You ask 3 wise guys, a question, and you get 4 answers. And similar with IoT, right? There are people who talk about IoT, and then there are people who are looking for IoT, and somehow they all can agree on that it's called IoT. But beyond that, Cisco talks about something which is completely different from what GE talks about, and yada yada. So IoT is just this wonderful canvas everyone can project their imagination and their dreams on, but you will be hard-pressed to find what really IoT is. So let's look at it a little bit from a technical side. So the Internet of Things. So and when you're I assume most of you are technical. When you think about the internet, right, you think about topologies and maybe everything talks to the cloud, or maybe things kind of talk in domains with gateways, and then you have an internet of gateways and yada yada, right? So that's kind of what we think of the internet. And then, of course, there are things, and I have yet to find an engineer who doesn't kind of get big eyes about 3D printing and all that cool stuff you can do with it. So that's what we engineers think about things. So, but then when you go out and talk to other people, what they actually associate with the Internet of Things is 2 things. They have the internet to talk to each other, to communicate, to do Skype, to do Facebook, to do chat apps. And then there are things. And since we're in London, who knows this? It's called Good Night Lamp. Who knows this? Oh, there are 2, 3. Okay. I'm going to do a little side pitch here. There's an awesome conference in beginning of December here for everyone who's interested. It's called ThinkMonk. It's from the Redmonk consultancy. Go there. It's really a complete different IT conference with a lot of designers and creative people. Anyhow, this is where I stumbled across this prototype product. I think they're now on Kickstarter, or they have been on Kickstarter. It's called Good Night Lamp. So why do I like this project? To me, Good Night Lamp really kind of embodies what the Internet of Things for most people will be when it comes. And it's very simple, right? It's a pair of houses, right, with lights in it. But the trick is that if this one is switched on, the little one is switched on, and vice versa. So the designer, who's actually here in London, she put up an awesome YouTube video. And so you have to imagine the scene is like a family where the kids are all out of the house, right? And they're in different places around the world, different time zones, etc. So, and as they go through their day, all the kids have essentially the big lamp there, right? And as they go through their day, they kind of tap it, light goes on. They kind of tap it, light goes off. Maybe when they go to sleep, they tap it and the light goes off. And then correspondingly, the little light goes on and off. Similarly. And so on the parents' place, you have this 4 or 5 little lights, right? And they go on and off as people go through their day. And I thought personally that this was a great way of showing the potential of Internet of Things, which is like, what is more simple than light and touch, right? And connecting things. And I thought the good night lamp is a great example in a very simple way about teaching us about presence, about touch, about light, about seeing, about other people getting, showing their presence in our lives. And ultimately, I think if we see how people use the internet, that's how the Internet of Things will probably end up where products will come, which actually will have commercial potential, who kind of touch in, who kind of loop into this humanness about touch and seeing and presence. So anyhow, that was a little bit of a philosophical introduction. So, but this is a technical conference. This is an API conference. So how will the Internet of Things shape API design? Let's get started first. And we have had this in a bunch of presentations already. Probably everyone here, including Stefan, who is not technical, can design an API very easily, right? It doesn't, in today's time, building an API is actually not rocket science anymore. So, but what is hard is effective API design. And so what does effective API design mean? Effective API design means it has to meet our business objective. So now the next question is, so what do you mean business objective? What does that mean? So if you have some kind of marketing background or business background, you're familiar with the concept of a value chain, right? How a product kind of moves from, its origin all the way, and in every step there's value added in this. And this is called the value chain. And the one thing to notice with the API, when you look at this, right, APIs are a means to an end. And APIs give access to business assets. And that could be services or data, right? Google Maps gives you access to data. Twilio gives you access to services. So you have a business asset, and then you have an API provider who provides access. And this API provider doesn't just provide the API access, but it also includes things like service level agreements or end user license agreements. So it's almost like a contract. But the interesting thing now is that the API provider doesn't actually talk to the end user. No, the API provider talks to the developer. So the customer, and I think this kind of nicely continues the theme of what we just heard here, is the customer of the API is actually the developer, not the end user, right? So when we talk about effective API design, we talk about effective API design, which means the developer, which is suitable for the developer, not for your intended end customer or end user, but for the developer. Okay? I see you're still, by the way, I have done this presentation before. I'm more interested in interactions. So if you're disagreeing with me or you want to drill down, just please speak up. So I think it's much more. We are a small enough group here to have an interactive session. And that actually is something I like personally more than. So effective API design, meeting our business objective. Our business objective is to be the best API for that developer. Okay? Now, what does that to do with Internet of Things? So think about, I think if you look at this list, that's probably what most developer would associate with Internet of Things. It got to be low power. It got to be limited bandwidth. Many messages, asynchronous, autonomous, many connected application and systems, right? If you probably go to a bunch of IoT conferences and let people check up what are the characteristics of an Internet of Things application or a system, they will come up with some sort of similar list having similar attributes. Okay. Out of that, there is a whole zoo of new protocols who want to replace HTTP for your means of transport, for your means of API, right? So right now we're living in a world which is fairly simple, right? If you're working in big enterprises, you're probably having potentially some MQ in there, but everything else is kind of sitting on HTTP stuff. If you step into the IoT world, there's this whole zoo of protocols who all claim for themselves that they're going to be the HTTP for IoT. And if anything, if you kind of get a feel for all those protocols out of this presentation, I will be happy. So let's go through of them. Let's start with the granddaddy of all protocols, which is called XMPP. It's a protocol it's an XML-based protocol which was developed a long time ago, at least from an IT perspective, and it's actually a chat protocol. But what XMPP has done right in the beginning was to have an extension mechanism. So there's a lot of extensions now to XMPP which cover IoT-ish devices. And so the nice thing about IoT is you can also look at the term Web of Things, is that actually IoT applications often have similarities to chat applications. Think about your chat application, right? Someone comes online, well, you get a little green signal on your chat box, right? That you now can talk to that person. And you can talk, and then that person goes offline again, and suddenly that light kind of disappears. Similarly with IoT devices, right? They walk into a room, and they disappear from a room, or from some kind of car. A car enters a building, and suddenly there's a car the building can communicate with, and vice versa. So there's a notion of presence there. And if you look at what the W3C right now is doing, is they really map that very well into like what chat protocols used to do. So we have XMPP as one of the protocols of choice when people talk about IoT applications. Interestingly enough, XMPP gets a lot of detraction because it's XML based. And people feel like, oh, how can I possibly use XML in an embedded device? So our friends at IBM came up with something called MQTT. It actually is not far from here in Hursley Labs, which is the original home of MQ. They developed something called MQTT, which is a very lightweight pub/sub protocol. Very simple, a few byte protocol handler, and it has been open sourced through OASIS, so it's now an OASIS standard. Right now, that is probably the most popular protocol you have within the IoT community. Both companies and hobbyists are using MQTT for their connected X. Now, let's go all the way up. CoAP. Who here has heard about CoAP? Protocol called CoAP. Okay. So, not to be outdone, IETF favored a different protocol. So IETF is another standards committee, favored another protocol called CoAP. Now, CoAP comes from the REST side. So remember, MQTT comes from IBM, which with MQ pretty much invented the publish-subscribe protocols. CoAP comes from the REST side, and it's essentially REST over UDP. It has a straight mapping between HTTP REST to CoAP REST, but it also has a very interesting feature called an observer. So you can observe something, and then you get notified when something changes. So again, this kind of publish-subscribe pattern. Stomp. I included Stomp just because you can find it actually. It's also open source. It's a text-based publish-subscribe protocol. Stomp you will probably not find many people actually deploying, but I just wanted to show it because it's brilliant in its simplicity. It's literally text. DDS from the Open Management Group. They are also an old protocol which has been used in medical and logistics, like train networks, etc. They kind of, it's very interesting to watch, right? DDS kind of thought they're the protocol of choice for embedded systems. until IBM and Oasis kind of made that huge push of establishing MQTT. So DDS is now trying to race to get public awareness that they have been there first, and they're like a industrial protocol. They are currently mostly in the medical, in the defense, and logistics sector as an M2M protocol. And then I came across an interesting protocol called WAMP, which is a WebSocket protocol, which again combines RPC style with publish-subscribe. And all of those protocols essentially claim that they're much better than HTTP, and they will be the protocols you should be learning about if you're looking into the future. But I skipped over a slide, which is, if you thought that that is already kind of a zoo, look at that. So now there's a whole world of new frameworks out there who claim that they are the next framework, the next protocol / service layer for IoT. And ASP.NET and Socket.io is probably the easier one. WebSockets we know already, and they're very established. But WebRTC, it came out of conferencing over the browser, right? WebRTC is a great technology when you look at the demos, but they're still looking for that problem, right? And so now they're hoping to be the real-time web for IoT. The demos are awesome, but as you can see, they have a lot of competition. Who here knows Meteor? Okay, a few. So that's another protocol. It's a data, what is it called? Data replication protocol, DRP, something. So they have their own protocol to kind of do real-time web communication. Couchbase and Firebase. It's a very interesting pattern. So I was a hackathon, and I was supposed to help the attendants with APIs. And I noticed that it was about mobile apps, and I noticed that no one asked about APIs. And so I kind of, A, felt a little bit useless, and then B, I started worrying if I'm like on the wrong train in the industry. So I started talking to the mobile app developers, and they said, no, I know APIs, but I don't need it anymore. I use CouchDB. I said, what do you mean use CouchDB? And he says, yeah, I'm using the mobile client from CouchDB that gives me persistence and data synchronization, and I don't have to worry about it. So what happened was that CouchDB is a database. But where they hit gold was that they built a mobile client for iOS and Android, and that would encapsulate both data persistency and eventual data synchronicity. So they had a synchronization protocol running underneath. So you could run your mobile app in offline mode, which, by the way, is one of the things, if you think about, right, a lot of IoT applications assume that you're always online. But here you have a mobile app which also can survive being in some of those spots where you don't have connectivity. It still works. It still has some functionality. And then when it gets connectivity again, the persistence layer underneath simply synchronizes back to the main backend, right? So Couchbase, Firebase, similar model. Persistence layer, which kind of hides connectivity, data synchronization underneath. Anyone knows what that one is here? That model with a hand, kind of this? It's called FireChat. It's a very, very fascinating. It's called the company is called Open Garden, and what they do is true peer-to-peer connectivity. Meaning they rely, for instance, on phone-to-phone connectivity, and probably some of you at least are old enough to remember the times of Gnutella and BitTorrent and all those evildoers who were doing massive, scalable peer-to-peer networks with the explicit purpose that there is no central server which can be controlled and shut down and sued and something like this. They're using similar technology. Turns out iOS 7 actually has a peer-to-peer technology which you can use to build hop-to-hop networks with iPhones. They combined that with Android. So there are cities like San Francisco or New York where you have enough critical mass of people using FireChat that you essentially have a true to honest scalable peer-to-peer network which is not hooked up to Wi-Fi or cellular or something, but just simply of running around with your phone. And then they replicate, essentially, they relay information along those phones until they get to the next hub where they can go into the internet. So they just announced last week that they have now reached critical mass, that they want to switch that on as an IoT protocol or as an IoT network. The interesting thing is that they essentially have a complete different topology, which is very fluid, but which you also can't take out so easily, right? So it's not a command and control, not a central server cloud kind of, but it's essentially individual nodes kind of connecting each other, almost like a swarm network. Very fascinating technology. You guys should look it up. And of course, there's a lot of passion. And I include that. That was actually very relevant at the last Appicon in San Francisco, where people literally, not at the conference, but inside, where people were really kind of like, oh, you can't use HTTP for IoT. It's so dumb, And then this was back when Joe Speed was actually working for IBM, and Michael Holdman, who was an ex-MPP, said, oh yeah, IBM, I remember them. OS2 was supposed to be the OS of the future, right? And the reason I put that up is really, you have to realize that when you read about IoT, there is so much marketing hype around it, right? Where people saying, this is it, this is going to be the right application. And you kind of, I want to empower you and educate you a little bit that you can look through this. So when you look at those protocols, it always is useful to kind of trace back where the money comes from. So there is MQTT and Oasis are promoting MQTT. Also, the Eclipse Foundation is very heavily invested in MQTT. Eclipse, in general, is technology agnostic, but if you kind of look at where Eclipse comes from, it is clear that there's some affinity to IBM and its marketing power. CoAP. ARM just bought the company which is commercializing CoAP. So you can expect that ARM will be pushing CoAP as the protocol of the future. XMPP, you find a lot of the not old guys, that's the wrong word, but a lot of people who have invested already in XMPP from the old times. They are promoting that, etc. So I just want to, when you look at this and you read about how MQTT is going to rule the world and you shouldn't be investing in HTTP anymore, think about who is saying it and why they're potentially saying it. Okay? So now I have a bunch of slides where I actually want to pose if IoT right now is kind of suffering of this kind of groupthink, where everyone just runs in the same direction just because everyone else is running in that direction. So I had a very interesting discussion. A lot of the protocols claim that there's so much less power and so less compute cycles than, for instance, HTTP. There's always this claim that HTTP is somehow too big, too fat for embedded devices. The fact is, where are most of those IoT devices going to be, especially for the consumer space? Well, they're going to be on you. They're going to be in your home, they're going to be in your office, or they're going to be in some kind of public infrastructure. Now, chances are that in all of those places, there's either Bluetooth or Wi-Fi, which pretty much eliminates the limited bandwidth problem, right? In addition, everything which has a building around it probably has power, right? I have no power problem at home. So this whole notion of that it needs to be low power, I don't know. Maybe there are special cases, but I think in a large number of cases, it will be just sitting in the power slot in a power plug, like a lot of other things. Many messages, we come to that in a second, and then many connected application systems. The orthodoxy right now seems to be that everything has to talk to the cloud. I don't understand why. If I have things at home, why shouldn't they just talk within the home, right? Well, why do I need the cloud for that? Or if I have things like a Fitbit, right? I mean, why does that need to talk to the cloud? Why can't it just talk to, I don't care. I don't want to have my stats being shown to other people or something. There's actually some interesting exploits of people who were wearing their Fitbits during activities in the evening or at the night, which then were clearly showing as spikes in their charts. So you could, there were some people pointing out and tweeting, oh, X, Y, and Z had last night, seemed to have had a fun night, right? So I don't need people to know that. And by the way, that was going to be interesting to see with the Apple Watch and stuff like this. So, so many connected applications, maybe they're all within just domains, right? There's a model where things just talk with each other in my home, and then maybe there's a boundary gateway where an aggregate of that is shared with the next entity up, which is maybe the building, and then there's another aggregate which shares it with a district or the city quarter or something, right? I don't believe that everything has to talk to the cloud. Now, and here we come actually to hypermedia. What I do think, two trends which will impact API design are those two, asynchronous and autonomous. Asynchronous because things just happen, right? If you think about your phone, right, push notification. Well, in a lot of cases, push notification is actually something called a long poll. Your phone is actually polling the server if there's a message for you, right? And they use some tricks. They kind of stretch it all the way almost to the timeout and then kind of do this again. That's not push notification. That's just a modified, it looks like a push, but it's actually a poll, right? And that's not scalable. So a door should just tell me when it's open. I shouldn't have to keep asking, has it been open, has it been open, has it been open? So there is definitely going to be a trend towards pops up kind of patterns in the space versus the current request response pattern of HTTP. And autonomous is another fact. There are a few companies out which seems to be ingenious in getting you to switch your phone every 1 or 2 years, right? Brilliant. I'm not going to do that with my toaster. I'm not going to do that with my washing machine. I'm not going to do that with my refrigerator, etc., right? So as things get more embedded, chances are the life cycle, the longevity of those products are different. And so when you embed intelligence into those products, they need to be able to live there for 2, 3, 4, 5 or something years, right? And this is actually where API, and I don't know who has ever released an API into the public. They are both a benefit and a curse, right? The moment people use that API, you can't just change it anymore, right? People get really, really angry if you change your working API. And versioning an API, I would say after the second or the third time you have done it, it's not fun anymore, right? So, and this is actually where hypermedia comes in. Hypermedia would actually allow us to build APIs which are more change resistant, right? Because in hypermedia, I don't know if you guys know how that works, right? In hypermedia, you are not coding in the URIs of the endpoints, right? You don't put so much logic into the client, but instead the logic reacts on what the server response tells you, right? Mike Amundsen, who's part of my team, he's O'Reilly hypermedia guy. He actually has a great example. It's like a maze, right? Imagine your API being like a maze. You have the resource in one state, and now the resource or the room you're in tells you where you can go next, right? You can go left or you can turn right. So similar, if it's a washing machine, you get the status back from the washing machine. It tells you you can switch me on, or you can, I don't know, it's probably the only thing you can do. So once it's switched on, it tells you, so now in the response message, it tells you I'm switched on, you can now switch me off, or you can pause me, right? Or you can get status from me, right? And so the client would essentially be able to kind of walk that API description to understand what it can do at that point. So it reduces, you take out hard-coded knowledge of the client and put it in the interaction design of the API. And that will ultimately enable you to build clients which are living longer and more change-resistant than, for instance, our current design, which changes every time you remove or add an endpoint. Yes?
Are there any well-known, for examples of APIs that actually do that?
Hypermedia APIs? Yes, there is Amazon just did their, how's it called, AppStream, app something. So there are a bunch of APIs now. There's the latest one from Amazon was a hypermedia API. And I tried to think there was even a project, an IoT project, which was having one. I look it up and we can talk afterwards. But fair enough, hypermedia right now, with like microservices, is something which is heavily debated. There's a lot of papers and stuff. But I think what scares people away from hypermedia is just simply the amount of work you have to put into the client. And I think until we kind of see the first reference designs of clients, you can kind of pick up from GitHub, fork them, and just use them with maybe JSON LD or Hail or Uber or something like this. Probably hypermedia will still be a debated concept and not a really implemented concept. But this talk is about the trends which are going to impact us 2 or 3 years out, and I think hypermedia has a chance to address some of the challenges around autonomous clients who are long-living and have to be somewhat more change-resistant. Okay? So I touched on this already, right? I've kind of started to become very passionate about trying to puncture some of the myths, some of the groupthink in IoT design, which is, is really everything outside where there is no power supply and no network connectivity, et cetera, or is most of the stuff people are proposing close to a power source and close to a Wi-Fi, meaning we can use whatever we know today rather than inventing new technologies. So this is some of the questions. This is the thing, right? I still have a Fitbit. My wife gave it to me some Christmas. I don't know why. Maybe she felt I was starting to grow in the wrong directions. But in the beginning, the first 2-3 months, and actually this is confirmed by studies, right? In the first 2 or 3 months, I went and checked on the web if I looked at the stats and the graphs, right? And then it became less and less, and then I didn't use it. And ever since I heard about those people who find out what other people did at night when they were wearing a Fitbit, I have disabled that functionality. I'm not wearing it at night anymore. So don't get your hopes up. But I'm also, I'm not using the web interface anymore because the Fitbit has a little interface which tells me, how active I was during the day. And to be honest, that's the job I want this thing to do. I just want to either feel like, okay, I did enough today, or the feeling like, well, maybe I should go for a walk around the block. I didn't move much, and that's ultimately what I want the Fitbit for. But I don't need to have it connected in the cloud. And I think there's a lot of products out there who don't need to be connected in the cloud, yet still provide some value to the user to buy them. The other thing, a lot of messages, right? There seems to be a thinking that I can only do data analytics in the cloud, right? Big data. Now, I have a problem with that when someone calls me a user and not a customer, because usually a user is something I use to get data, which I then sell to my customers, aka the Google business model. And I think if you look at the development of hardware, actually compute power is getting cheaper and cheaper, right? Intel just came out with a new chip, which is incredibly powerful. It's an x86, then the Raspberry Pis, the Arduinos. So the question is, do you really always need to calculate in the cloud? Or would it be more honest that you kind of provide value to the people who are using your service and ask them to pay for it rather than trying to sell that data to someone else? So, and this is actually the thing I fear the most. If you think about where we were like 5 or 6 years ago, right? We were in the SOA space. And then came REST around. And so why are we having, we never had like SOA conferences, right? No one was excited about web services that they would go out and build entire business models on it. You're agreeing or you're disagreeing?
I remember the round of SOA conferences very well.
Oh, you're saying that they were there?
They got hold of it.
Okay. So REST did a few things which were ingenious, and they have to do with removing choice rather than adding choice. It gave you 4 verbs to act with, right? It didn't allow you to do RPC style, here's my code, I generate a WSDL, and now you go and create a client from it. No, it gave you 4 verbs, and it gave you a URI for your endpoint description. And by removing all the other bells and whistles we had in web services, I think it actually created that breathing space where we could look at the interaction of that service and could redesign how we interact with that service, right? It's this whole idea of a resource-based API design. So the reason why APIs are so incredibly successful today is because they're so much more simple to use and so much more intuitive to use. But that didn't come because we just did a better job. No, because we had to redesign every API. You cannot write code which natively fits that API. You kind of had to redesign it from the outside in, or you had the chance to redesign it, which makes it more simple, more intuitive than web services, RPC-style APIs ever were. And if you want to have a proof point, look at Evernote API. They're using a complete different protocol. I don't know if it's protobuf. I think they use protobuf. But the point is, they have still an RPC-style API. You look at their list of functions, and it's huge. They have 70 different functions I can call in their API, and it's incredibly complex to figure out how to interact with the Evernote on that account. So I'm really concerned about that IoT essentially gets us back into RPC-style interactions of code-driven interactions, which takes away the very foundation of what made APIs work today, which is simplicity, self-service, low barrier to use, right? And that's really where I see the biggest concern, that people will start building this closed ecosystems, this kind of closed gardens and hard to use APIs again, like we had with the web services days. So if you ask, what kind of advice I can give you in terms of what protocol to choose, what API to choose for IoT, I say, remember effective API design. Look at the developer, the maker you're targeting. Choose what they would like to use. So if they're using JavaScript and JSON, don't give them a web service API, right? Or at least do your homework. And this is something, you can look that up on Twitter. It's a concept called job to be done. It came from Clayton Christensen at Harvard Business School. And essentially, people buy a product to get a job done. So understand what is the job people want to get done through your API. And we heard that from Adam here just now. It's essentially base your design choices, your technology choices on the job those people want to get done through you, not on your likings or the latest hype or any of the other things people. Yeah, so that's my advice. I hope I gave you a little bit of an overview what's out there right now. Google it. There's a wealth of technology out there, but again, understand that there's a lot of hype. People want to be the next HTTP and want to claim that they are right, and to just kind of give you a counterweight. There's plenty of technologies out there, in particular webhooks and stuff like this, which even today with HTTP you can achieve a lot of the interaction designs we talked about, like publish, subscribe, etc. And so it doesn't necessarily need to mean that you have to go for a new protocol stack or something new, but you can also evaluate if some of the existing technologies around HTTP might just do the trick. Thank you for listening, and enjoy your coffee and cake. Thank you.
Brought to you by MuleSoft, provider of the industry-leading Anypoint platform for APIs.